Hi, I'm Pat Kelly. Okay, for this problem, they've given us a differential equation and they've given us an initial condition, and our task is to find the particular solution to this equation that's going to satisfy that initial condition. So my first step here is going to be to work with the differential equation and find the general solution. So I'm going to try to attack this equation using our separation of variables technique. So I'm going to start by manipulating this equation just a little bit, maybe even as a very first initial step. Let's rewrite that y prime. Make sure you know what it looks like in maybe a different version. That's the derivative, which I can write as dy dx. Those are of course the same, but this notation makes it a little bit easier for me to see how to separate the variables. Let's carry through with the rest of the equation. And now I can try to separate those variables with a little bit of algebra. So I'm going to subtract that minus 2e to the x term to the other side, actually add it. I get y dy dx equals 2e to the x, just an algebra step. And one more algebra step is going to take that dx in the denominator and multiply it over to the other side. And we'll have our variables separated. Okay, separation of variables, and now we're going to integrate each side in order to try to find y. So in this step, I'm integrating each side. Now I'll actually go ahead and dive in and do the integration. So the integral of y is y squared over 2. And on the right-hand side, the integral of 2e to the x is 2e to the x plus c. So that's my integration. And I'm going to take one more step here real quickly just to kind of clean up. I'm going to get that 2 out of the denominator and actually clear the entire equation of fractions just by multiplying by 2. And here we get to the case where you're actually multiplying that c by another constant. Let's just call it c again, but that makes me back up and call the first one c sub 1. So it's that bottom line of my work that's my general solution. And now we'll use that general solution and the given initial condition in order to find that particular solution that we want. So I'm going to take this general solution and plug in a 6 for y and a 0 for x. Let me rewrite that general solution first. Now I'll plug in the y was 6. Equals 4e raised to the 0 power plus c. I'm not sure if the colors showed up real well for you there or not, but x equals 0 and y equals 6. And now I'll simplify. 36 equals 4e to the 0 is 1 plus c. Solving for c, c equals 32. It's really all we're always doing with our initial conditions is plugging into the general solution in order to find an exact value for c. And so our final answer comes back to the general solution, but we put in that value of c that we found. So I'll say plus 32. This would be my ultimate final answer of the particular solution to this differential equation that's going to satisfy the initial condition. Okay, hopefully that helped. Thanks.